the art of tower crane operation, anti-sway, phase control, and oscillation energy management. Opening. This is a long-form training talk about one thing: how to operate a tower crane at the highest level. Not just moving loads from A to B, but doing it cleanly, safely, and with control, so the hook and the load don't start living their own life. This is not a manufacturer manual. It's not a replacement for your local regulations, site rules, or lift plans. Always operate within the limits of the crane, the charts, the wind restrictions, and the procedures. What I'm describing is a skill layer, a professional approach to motion, often called anti-sway, sway suppression, or payload swing control. I want to explain it in the simplest possible operator language and then translate it into more technical terms, so you can connect practical experience with how engineers describe the same thing. Here's the key idea that frames everything. I'm not only controlling position, I'm controlling oscillation energy. Position is where you want the hook to end up. Energy is what makes the hook keep moving after you've stopped. When operators struggle, it's usually not because they can't reach the target point. They struggle because the system keeps swinging, and then they're forced into waiting, fighting, or doing big corrections. That's what kills cycle time, increases risk, and creates stress for everybody on the ground. So, this is about learning to avoid injecting energy into the pendulum in the first place. If energy is injected by wind, by geometry changes, by speed demands, learn how to remove that energy smoothly. That's the art. Chapter 1, the crane is a pendulum system. Let's start with physics, but in operator terms. The hook block, the chains, the slings, the spreader, whatever is hanging, forms a pendulum. If there is a load, it's still a pendulum, just heavier and sometimes more complex. Even with empty hook, it's a pendulum. A pendulum has one brutal rule. Any sudden change in motion becomes swing, not might become swing, it becomes swing. Because the hanging mass wants to stay where it is in space, and the crane structure or the hook suspension point tries to move away. The difference becomes oscillation. There are several ways the crane injects energy into the pendulum. Start impulse, a sharp acceleration at the beginning of slewing, trolley travel, or hoisting. Stop impulse, a sharp deceleration at the end. Mid-course impulse, speed changes that happen while the pendulum is already moving. Coupling effects. Slewing causes apparent outward push, and if trolley isn't managed, the hook gets thrown tangentially or radially. Wind. Wind adds energy and changes phase. Rope length changes, hoisting up or down, changes the natural frequency, so timing changes. You can think of the hook as having a preferred direction of swing at any moment. If you feed it at the wrong moment, the amplitude grows. If you act at the right moment, amplitude shrinks. In control theory, this is why people talk about residual sway. That's the swing left after the crane has reached the target position. And residual sway is the enemy of clean work. Chapter 2, typical operator behavior versus high-level behavior. A typical operator often drives the crane like this. Start the motion, hold a steady speed, stop the motion, then wait or fight the swing. This is not because they are bad people, it's because that's how we naturally think. I want to rotate left, so I rotate left. But a high-level operator adds a second layer. They don't just command motion, they shape it. High-level behavior looks more like start smoothly, avoiding an impulse. Maintain the motion while keeping the hook stable. Finish with an intentional stop that leaves the hook close to zero swing. If swing appears, apply small corrections that remove energy instead of adding it. The difference is not necessarily speed, the difference is control and end-state quality. When you see a truly professional crane operator, the hook looks like it's on rails. Even with long rope, even with changing radii, even with slewing, the hook doesn't explode into big arcs at the end of every move. And that is not luck, that's skill. Chapter 3, the mental model, oscillation energy management. Let me explain what I mean by controlling oscillation energy. The pendulum has energy in two forms. Potential energy when it is displaced. Kinetic energy when it is moving. If you stop the crane and the hook continues swinging, that means it still has kinetic energy. If the hook is far out to one side, it has potential energy, which becomes kinetic as it falls back. As an operator, you are not calculating equations in your head, but you can control what matters: how much energy enters the system, and how quickly energy is removed. Think of every move as either feeding the pendulum or draining the pendulum. If your inputs are poorly timed, you feed it. If your inputs are well timed, you drain it. That's why people also use the language of phase and counterphase. If your correction aligns with the swing direction at the wrong time, you amplify it. If your correction is timed correctly, you damp it. In the engineering world, one family of methods is called input shaping or command shaping. The idea is, if you shape the acceleration profile in a specific way, you can reach the final position with minimal residual sway. Another family is energy-based control. You build a control law that reduces the swing energy over time. As an operator, you can practice a manual version of both concepts. Chapter 4. The 3 critical moments: start, change, stop. Most swing problems are created in 3 places: the start, the change, the stop. Let's go through each. 1. The start. If you start hard, too much acceleration, your very first impulse becomes swing. So the rule is soft start. A soft start doesn't mean slow. It means smooth. It means you ramp into speed. You don't jump into speed. 2. The change. While you are moving, if you do nervous corrections, quick changes of speed or direction, you are injecting additional impulses. That can create chaotic swing patterns. So the rule is small, smooth corrections. 3. The stop. The stop is where the biggest residual sway often appears. A blunt stop means you reach zero crane motion while the hook still has its own velocity. That leftover motion becomes a big arc. So the rule is intentional stop. An intentional stop means you are thinking, how do I stop the crane so the hook ends in a calm state? That is the difference between arriving and arriving clean. Chapter 5. Slewing. The most misunderstood source of swing. Now, let's talk about slewing, rotation. Slewing is special because you are not just moving the suspension point in a straight line. You are moving it around an arc. That introduces tangential effects and feels like the hook is being pushed outward. What many operators do, they rotate and they ignore trolley management. Even on empty hook, the hook drifts out, then it swings, then they stop, and the swing continues. A high-level operator treats slewing as a combined motion problem. Slew plus trolley plus timing. The aim is to keep the block and chains as close as possible to a zero dynamic line, meaning small deviations are normal, but you prevent the amplitude from growing. Here's the most important point. During slew, if you do nothing, the hook tends to lag or lead and then oscillate in the frame of the jib. The swing plane can look like it rotates relative to the crane. So, your job is to keep the system from building swing while you rotate. That often means not applying a big acceleration step at the start, not applying a big deceleration step at the end, using trolley micro adjustments to keep the hook from being thrown outward, and finishing with a stop that cancels residual motion. This is exactly where experienced operators look magical, but it's just energy management. Chapter 6. Counterphase corrections. How to remove swing energy. Now, let's say swing exists. Wind, long rope, heavy load, tight schedule, swing happens. The question is, do you wait or do you reduce it? The lowest skill strategy is stop and wait. Sometimes that's required for safety, but it costs time and it doesn't teach control. A higher skill strategy is apply corrections that remove energy. This is the essence of counterphase operation. How to understand it without equations. Watch the hook. It has a rhythm. If you accelerate or decelerate at the wrong time, you push the swing bigger. If you do it at the right time, you cut the swing down. The important detail. Your corrections must be small and smooth. Big sudden corrections often add more energy than they remove. They also create secondary swing axes, like twisting or load rotation. So, the operator's job is to do minimal input that achieves damping. In practice, damping can be done by slight adjustments of slewing speed, slight trolley adjustments, occasionally small hoist changes depending on crane and geometry, And most importantly, timing the final approach so the hook ends calm. Chapter 7. Coupling. Why top operators blend motions. In a tower crane, you rarely move in only one axis, especially in real construction environments. You combine slewing, trolley travel, hoisting. Each axis affects swing differently. Slewing influences tangential swing. Trolley influences radial swing. Hoist changes the pendulum length and frequency. A lower skill operator isolates axes. Now I only slew. Now I only trolley. A high-level operator blends axes. They do not wave everything randomly. They blend motions with one intention: keep the hook stable and minimize swing energy. If the hook drifts outward during slew, a small trolley correction can keep it centered dynamically. If the rope length changes, the swing frequency changes, so your timing changes. This is why people say long rope is harder, because the pendulum is slower and timing becomes more sensitive. But with the right mental model, it becomes trainable. Chapter 8. The empty hook discipline. This is where most operators lose professional points. They treat empty hook like it doesn't matter. But empty hook swing can still be dangerous. It can hit structures. It can hook something. It can force you into corrective actions that waste time. And it builds sloppy habits. A professional operator tries to keep block, chains, hook, stable in motion, even when empty. Why? Because it builds the foundation for loaded work. If you can keep empty hook stable during slewing and stopping, you can do it with a load. So I recommend a training discipline. Practice anti-sway with empty hook repeatedly until it becomes automatic. Chapter 9. Training drills. Here are practical drills. Do them only in safe conditions, within sight rules. Drill 1. 90-degree slew, swing-free stop. Start with empty hook. Slew 90 degrees. Your goal: stop with minimal residual sway. Don't fight at the end. Shape the stop. Repeat many times. Drill 2. Slew plus small trolley correction. Slew slowly. Make tiny trolley inputs during slew to keep hook stable. Goal: the hook should not drift outward significantly. Drill 3. Trolley travel, clean stop. Move trolley out and back. Focus on smooth start and stop. Goal: settle quickly without waiting. Drill 4. Hoist up parking without swing. Raise hook to parking position. Do it without starting swing. Goal: no side oscillation while hoisting. These drills are not about speed, they're about quality. Chapter 10. A short pro checklist before any move. Before you start any significant move, ask yourself, how will I start smoothly? How will I finish so I don't leave residual sway? If swing appears, what is my minimal correction path? Do I need to blend axes to keep stability? Is the environment tight, windy, or sensitive? This is how you turn instinct into deliberate skill. Chapter 11. Translating operator skill into technical language. If you want to connect this to engineering terms, here is a clean mapping. Don't create swing corresponds to input/command shaping and sway-free trajectory planning. Remove swing energy corresponds to energy-based damping, Lyapunov methods, and passivity-based control. Small counterphase corrections corresponds to feedback control applied with correct timing. Blend slew and trolley corresponds to multi-axis coupling in 3D crane dynamics. Your manual technique is basically a human version of those methods. The difference is, you are the controller, and that is why high-level crane operation is a craft. Closing. If you take one lesson from this entire talk, it's this. Top-level tower crane operation is the ability to avoid injecting oscillation energy and to remove it when it appears, especially during slewing and stopping. This skill reduces risk, saves time, and creates a calm, professional flow on the site. Train it with empty hook. Train smooth starts and intelligent stops. Train micro corrections, not big fights. And over time, the hook will look locked, even in challenging conditions. That's the art.